part in today's webinar. We're very excited to continue to build, strengthen, and grow our partnership with the University of Kentucky. During these crazy times, I think one of the key things to take away is our human ability to adapt and adjust to any environment, any situation. And I think nothing is more indicative than the fact that we're all meeting here virtually on Zoom meetings today. On that note, I'd like to introduce my colleague at M3, Conor Delanbanque. He is the head of our global DevOps practice. Rather than start to build, I'm just going to hand it off directly to him. He has a very exciting presentation ahead. I just ask that if you do have any questions, feel free to hold them to the end. We'll definitely answer as many questions as possible in the allotted time. And I'd also love to give you a little background of M3, the work that we do, some of our current hiring initiatives. And on that note, I'll pass it over to Conor.
Thank you, Lewis. And just before I begin, it's always good to kind of know my audience, and given that there's only a few of us in the room, if I could just ask the question, are you guys students of the university? Are you in the staff from the school, the College of Engineering? Is there a mix of everyone? Maybe if someone could answer that for me as well.
I believe I am the only student here. I think everyone else is staff or faculty.
Okay, thanks for that.
Faculty, and then you have Kim Sayre. You've met Kim before over the email. And everyone else is faculty or retired faculty.
Okay, great. Well, lovely to meet you all. As Lewis mentioned, I'm Conor. I'm currently in New York City in my apartment. So disclaimer, if you hear a little dog barking, that's my dog. There's nowhere else to be. So he usually wants his lunch walk around 12:30. So maybe he'll bug me at the end. And I'll try to keep, I know we had a sort of 12 through to 1 booked. I'll try to keep it towards the end of there, and then we can have some questions at the end as well. So essentially, what I'd like to cover is really what we're going to get into. What is DevOps? How it's applied in the in the real world, right? So not just how we're using it to study or to teach, but also how it's used in practice in financial services companies, in insurance companies, law firms, everywhere that consumes and uses technology. I want to kind of give an overview of that, some of the tools, the technologies, and the practices. But also, I'll kind of give you guys an insight at the very start, because we're in a really interesting time. I don't think it's all doom and gloom. This is a time where technology can shine, and there are true real world winners and losers in scenarios like this. And I obviously don't want there to be losers, but that's the reality. So I'll talk us through kind of how that impacts things first, and then I'll move into the tech side of it. And then at the end, I think I'll probably bring us closer to the application of how can someone leave somewhere like the College of Engineering and get a career using some of the things we've discussed today. Just so you're aware, in terms of my background, so Lewis has mentioned I'm the global head of DevOps practice at M3. So outside of that, I run the Durable DevOps podcast, which hosts people like chief technology officers from companies such as MasterCard, Bloomberg, ADP, and others. I speak at DevOps Days, Cloud Expo, DevOps Summit. The most interesting place I spoke was in Cuba at a technology conference, would you believe? And outside of that, I also write articles for DevOps.com and OpenSource.com. I'm a community moderator for OpenSource.com. So I speak to a lot of interesting people. I see a lot of companies doing well, and also some that don't do so well, depending on how they do some of the things we'll discuss. So we have this word DevOps. You'll have heard it many times. There's always questions of, is this a buzzword? Is this important? It's definitely not a buzzword. It was first thought up around 2008 by a man called Patrick Dubois in Belgium, where he made the DevOps Days conference, the first ever one. And back then, people were talking about how do we bring developers and operations closer together. So where you would develop your code, you would write a large application at times, which could take a long period of time. And then you would pass your work on to the next phase in the software development lifecycle to someone, for example, to do testing. that testing process could take 6 weeks. And then you could also find out that you have to make some further changes to your code before it's sent to production. We could be looking at things like 3-month or 6-month cycles from an idea, a conception of an idea, through to getting your code into production, which is a very long time. And in the age we're in, where we want things quickly, we want to be able to make changes and get them to our consumer as quickly as we can. So that's something that, kind of the initial base idea of what DevOps is and what it was, and it's become much more. The way I define it is it's a collection of practices. It's a methodology, and that methodology includes people, process, and technology. So before I delve into that, I'm going to give you right now the idea of what's actually happening in the world. So we all suddenly are working from home. We have large use of cloud computing, of automation that other companies have built for us that we consume. Zoom, our internet services, our Netflix that we watch in the evening. The list goes on of the things that we're all consuming daily. Mostly hosted in the cloud, mostly using very, very fast and modern software processes. And all these companies are using these DevOps practices. So it really relates to transformation and modernization of large-scale corporate companies. So when you look at the day that we were told to suddenly start working from home, so in New York's case, that was around 5 weeks ago, we began this lockdown. There were some companies who pivoted immediately because their processes and their culture of their company, not just the technologies, but the people and the process aspect, was modern. It was up to date, and they had been through a transformation. If they're a large company that's been around for many years, they'll have gone through a transformation. If they are more of a startup or a new tech company, they may be grow into this. It's very much a native growth into cloud, into DevOps. So you've got this quick transition where if you provide a service, we're not talking about the bars and the restaurants that of course have closed, and the retail companies and everybody else that's had to shut their doors, unfortunately. We're talking now about the companies who, like M3's example, I'm able to do my job daily from my apartment. My customers, let's think about companies like Bloomberg, let's think about large banks. If one large bank can pivot, so if JP Morgan can handle working from home suddenly with 300 or 400,000 employees, we're talking maybe more about their services like investment banking and their tech services, their mobile application, their desktop application, and so on. If they can provide that service to the customer while they are remotely distributed, they are going to get ahead on their competitors. And myself and others in this space who have been talking about DevOps practices, DevOps methodologies for, me personally, this is I think my 6th year of discussing these type of things now. So even since the early days where people didn't really think of it at this large scale, we've seen a very big transition. So back to the JP Morgan point, we've got a large bank and we've got another bank. Let's just throw out a name. Let's say Morgan Stanley as their competitor. If Morgan Stanley could not get laptops to their employees, if they didn't have their remote access for those people, if they didn't have security implementations in place, there are so many different things that these large companies need to have to be able to suddenly work from home. So that alone is the people and the process that we're referring to at the very beginning of talking about DevOps. We're thinking, how can we make changes to our company and our people without it impacting our workflow? And so they would have been simple things like collaboration tools, Zoom, Microsoft Teams, Slack, or internal chat, instant messaging tools. If they were already using these, if they have modernized, so during this modernization process that many companies have gone through, probably only in the last 5 years or so, they'll have started using these types of tools already. And if you're using them at home, you have not just the use of something like Slack or Zoom, there's actually a culture to using it. For example, using GIFs, using emojis. What you have there, if you're part of a team, let's say we're all a team of software developers, let's say the people in here, the 9 people in this conversation, we're one team, and we have already been using this for 5 years already, or 2 years. If you interact with me remotely and I am fun to work with and I'm kind to you and I'm sending these emojis, I'm making this interaction more positive, you will find it easier to work with me, and you'll be more likely to step in when I need to, do some firefighting with a critical application that we found a bug in that we have to remove or change. So the cultural aspect comes way, way before the implementation of these tools and technologies. We're talking about on a scale of 9 people in this room, in this chat room. But then if you scale that, and we're talking about 5,000 developers working together in different ways, you start to get the image of how important it is to have kind of processes in place, and not just processes. Then you move to the next step. Everyone needs to have the same version of the tooling you're using. So you need things like version control. You need source code management or source control to make sure that the source of your code is coming from, that you know where it's coming from, who was working on the code before you, how to interact with them, what the documentation pattern was. So there's a lot of this that applies directly to now in this current time, where I'm speaking from experience where I have seen companies unable to pivot, and the successful, the high performers or the higher performers, they have no issues with this because they've already begun this transformation. They've begun the modernization process. So I mentioned at the very start that the idea of a 6-month or a 3-month time from the beginning of the software development lifecycle being the conception of an idea through to deployment of the code or the application into the production or live environment. So that's the speed we're looking at in one example. That's kind of the lower performing end of the scale. And on top of that being the low performing end, like that 3 to 6 month phase, you also have to consider that there is also technical debt in these companies. And this is something that people are trying to repair time and time again. If you think about a factory that produces cars, if they only produced new cars and never worked on improving the machines, maintaining the machines, that's the problem we have in software. Because software is still so new that we don't have the age-old examples of things like time to maintain software in this instance. And you find that companies build up technical debt constantly. It's a term that may not be thrown around much in terms of during the time in your studies for computer science or any other STEM degree. But when you're in the real world, you'll realize there's lots of legacy applications written potentially a long time ago. And these applications will also have a lot of systematic complexity. So there's a lot of I've worked on that code, then Jersey has worked on the code, Jane has, then Lewis has, and over time you build up more complexity to how this application looks. And sometimes the readability changes and also the usability of that code. So what we're looking at in the higher performing example is not 1 year of technical debt, not 6 months of idea to deployment into production. We are looking at hundreds of deployments of lines of code per hour in companies like Amazon, Google, Netflix, Facebook, and the list goes on. So how are they doing that is really what we need to get to. And they're doing it through having good processes, having people that understand how the processes work, and having the technology at their disposal to do what they need to do. Generally, you'll find these companies work in cross-functional teams. So in the 9 of us here, we would all be engineers at heart. That's what this kind of comes down to. Really, everything is engineering now. So even if you work more on the ops side, which would be infrastructure operations, you would still be solving your problems using code, which is where we get things like infrastructure as code. And instead of just putting band-aids on our problems and trying to patch over our errors or our bugs, we will look at how do we re-engineer or build something that does not have that problem in the first place. So we do that by doing things like shifting left, where you're not just doing operations at the end of this process, where an engineer would build the application and pass that on to somebody else. You would actually be looking as everyone would have an understanding of infrastructure. Everyone has the ability in one team to read and write code. And we also bring that testing phase forward. So you have test automation happening earlier in this this software development lifecycle. So you have software development engineers in test. That's a fairly new job title, SDET, you can refer to in short. But that would be doing sort of the traditional QA, quality assurance role, where you're testing the code, but actually you're doing it using engineering. You're using automation tools to do this much faster. And to put it further out there, that if, for example, I'm in your team, if there's 9 of us in one kind of, you think of it as a product team or a cross-functional team, if I am the lead developer, but I'm off sick for a week or 2, you no longer have to wait for me to be back to ask questions or to work on my code, because we're working in this team using these practices that I'll elaborate on further now. So some of those practices, as well as the things we've just discussed, we're looking at continuous integration, continuous delivery. We're looking at configuration management and provisioning. We're looking at cloud computing, and then containers, as well as container orchestration. So to the first piece of CI/CD, which is continuous integration, continuous delivery shortened, we would use tools like Jenkins, Bitbucket, Travis CI, Circle CI. By far the most common, I would say, is Jenkins. And so the way I look at CI/CD is it's the conveyor belt. So if we're looking at this, I'll try and use kind of examples in the real world for us to see what we're looking at, but we're looking at it as if it's a conveyor belt in that manufacturing line, and that conveyor belt moves automatically. So if I'm putting the code that I've written into this shared repository, into this continuous pipeline, you, as my team, will see the work I've done so far. You'll know what needs to be done that I haven't already worked on, and you'll know how it integrates with what you're doing. So all of our code is integrated together, and it's moving automatically through this process. It's not a randomized process. It's completely something that we as a company would have built. We would create the systems that we work with. A lot of these are plug and play and very easy to use, hence the increased use of automation. But it's very much a system, and we've built it in a robust way. It's durable, and it's not like we brought someone new into the team, they're able to write some bad code, and it just gets through the system and goes into production. We would have checkers in place, and we would have our own review system that allows us to see what's good and what's not. And that's really what this is about. It's about building systems that can let people exercise their creativity in software development without having the failure and the blame culture that other people might have in lower performing companies or organizations. So we can fail. There's no problem with that. Let's fail fast. So let's find out what the problem is. Let's do it, make the mistake, and then fix it very quickly. Often the fix can be done automatically. And that's how you're able to do things very, very quickly in these modern software or modern engineering environments. So you've got your CI/CD process, the very start being kind of the build aspect. So CI being the beginning of build, and then moving through to the CD, the continuous deployment or continuous delivery phase. And you can do, in high performing organizations, or the higher end of the scale here, we're talking about getting your code into production, and often zero touch. So not even having to have somebody else review the code, because you trust your system to that extent that if there was a problem with the code, it would be caught by, automatically by the system that you've already built. Or you could have a scenario where Jenkins gives you an automated message at 5 p.m. every day and says, do you want to deploy? And you say yes. So there's a kind of a balance of how this can work. And a lot of people do have it as kind of a last checkpoint for a human to interact with the automation tool. So moving from kind of CI/CD as our pipeline, you also have, where you host, where you store, where your compute power comes from, and a variety of other toolings that we can use within cloud computing software. So Amazon Web Services, AWS, Google Cloud Platform, GCP, Azure, they're by far the 3 most common public cloud tools that we have available, but then there are others as well. And then also at some organizations, so you'll find a number of banks would kind of replicate what they see being done with public cloud, and then these financial services organizations will build their own internal private cloud system as well. So occasionally you'll see stories of, okay, Amazon Web Services had this terrible bug, it went down today, but they actually had situations where maybe certain users left things like their S3 storage buckets open, and there was someone was able to get in and essentially kind of penetrate the system. But over time, we have seen a lot of improvement with public cloud, and it's quite trusted by so many of the Fortune 500 companies. So the use of this cloud gives us that freedom to work faster, to have elastic access. So if you're working in retail and Black Friday weekend is coming up, you're going to need sudden spikes in usage, and you would have that elasticity if you're using certain components of public cloud software. So that's kind of one aspect of it. So we've got CI/CD, we've got the overarching cloud computing, which is, or you could think of that really as, at the scale of our internet, that's kind of not having cloud in the near future would be like not having internet. And even now, I would say that that's kind of the stage we've got to with most high performing companies. And then we then go to the use of containers. So Docker is very common, and I'd say the most widely used container system that we have. And then you have orchestration of our containers as well. So you'd have Kubernetes is a great example where we're using currently for the same. So there's kind of a number of tools and technologies that are used. What we really are getting to though is kind of why we're using them and how they are leveraged at scale, because what we do when we're talking at the educational level, one way I describe it to people sometimes, it can be, the reason a lot of you are here is to figure out the best way to educate your students on things like DevOps practices, so you are keeping in touch with the real world. And I very much appreciate that you're absorbing this with me. But the reality is that education, is always trying to stay aligned with the market, and the market moves so quickly that it can be hard, even in one semester, to know exactly what's happening out there. So, often what we find is, and when we're studying as the student, we're trying to pass a test, but we're not always trying to think of the application, the exact application of what we're doing. In the same way that some students will learn Spanish for 3 or 4 years at that university level, and then they go forward and they don't necessarily speak Spanish in their day-to-day life and use it in real-world applications, and then maybe a few years later they're not very good at what they did. That can happen sometimes with engineering as well, right? We can learn what we're taught. The professors can teach to everything they want to teach, and they can do their very best. And the students can learn during that moment. And yes, they can pass the test and have a 3.5 or a 3 or a 4. What we really want to get the stage we want to get people to is where they're very closely aligned and they're bridging that gap with what is happening in the industry right now. And so I think really what we should be sharing with people is the what is aspect. So what is DevOps and why is it used? And I think that the closer we get to people understanding that this isn't it's no longer a buzzword. It's no longer reserved for, oh, okay, well, I want to do development. I don't want to do DevOps. That's not a reality we're going to look at for much longer, right? So even regardless of the times we're in and the changing in terms of, I mentioned COVID-19, working from home, remote work and things like that, the cross-functional teams piece is essential for everybody to understand. Everything is being done with development, with code. So even if someone is going the route of systems administration, systems engineering, even if they're working in networking or database architecture or database administration, the list of different job titles that people go into from learning technology skills is vast. But most teams in high-performing companies are working cross-functionally, and so they all need to leverage. So for example, if you didn't have that development skill, you would still be a great asset to many companies. But then the more that you can understand that DevOps is done by everybody, that's where we need to get to. So most of the companies that we're working with now that would want someone who works in a DevOps role, that systems experience is awesome because it's going to help them with understanding the bigger picture. But at the same time, if they could have engineering skills, so if they maybe come from one of the STEM degrees, but they've also learned some of the computer science pieces, algorithms, data structures, these are going to be very useful for just kind of that mindset, the logic-based thinking that we look for in these cross-functional teams. So I think that's kind of it. That's something that comes up quite a lot with the work that we're doing as well. There's another piece to it. You may hear about things like site reliability engineering. You may hear about platform engineering. A lot of these different roles are very, very similar to the core role that a DevOps engineer is doing as well. So one of my close contacts, he was a VP of engineering at Google, and his mindset is it's no longer the days of, okay, I wrote my code and it's not my responsibility once it's being tested. Someone else is taking care of that. QA takes care of it. It's not my responsibility once operations has that. They're taking care of deployments. This gentleman says that it's actually, as a developer, it's your responsibility until the code or the application is decommissioned from production, from the live environment. So you as a developer are responsible for the usability, readability, and performance of that code until it is decommissioned from production. Very, very different mindset to maybe some of the places that we all have worked, or even some of the places that some of the students will go into in the near future. It's not necessarily like that everywhere. You know, that's a Google example. He was also at eBay, so he's worked in some very high performing tech companies. But you can kind of see the image that I'm trying to build, in that a developer now, I think, is kind of responsible for this DevOps type of role. And a DevOps role is everything across the entire software development lifecycle. Once you have that, the idea or the conception of an idea from, let's say, a business analyst who would probably be part of a similar tech team or a product team, that would then be the engineer would write the code and build the application, and then they would support that through testing and through deployment as well. I've just had a question from Jersey that I'll look at. So that's a great question, Jersey, which I'll actually answer immediately, because I won't wait till the end for that, because it's a good question. So essentially that says, where is DevOps placed with respect to software engineering, a term used, for example, in your curriculum? So I think that it should be, you still should learn software engineering as it's a track. Software engineering is I think that DevOps is an overarching piece of knowledge. It's a collection of processes processes and methodologies and practices that encompasses as well. Now, I think software engineering is part of this. It still can be in a cross-functional team that if it was the people in this room, I, for example, could be I could be development minded, and then Jersey could be test oriented, and Ori could be infrastructure oriented. But all of us, if it was that 3-person team, we would all be able to read and write code. So it's no longer someone else's responsibility to do that for us. It's that we have to solve our problems through engineering skills, which is why software engineering still should be taught the way it's being taught. It still needs to have the core pieces of theory and practical assessments along the way. But I think that DevOps should be a part of this, or it should be thought of as everyone who learns software engineering should also be absorbing this knowledge of, you're probably going to end up in a team, if you're working in a tech team nowadays, that uses cloud computing. So it doesn't matter. So if you're a Java developer, there's the days of just knowing how to use Java are gone. And if you're going into a company that just do that now, they will be changing in the near future to start using what we're referring to. So it would be, for example, okay, I'm a Java developer, but I also know how to do things like CI/CD. So I would probably know Jenkins, Git. I may know some build tools like Maven and Gradle and Ant. And I would also know how to use some of the components of AWS, Amazon Web Services. So that could be EC2, it could be Lambda functions. And then I would also know how to use Docker to containerize my code. And so I probably wouldn't, as that kind of the core Java developer, I probably wouldn't use too many of the test automation tools. There may be a SDET, like a software development engineering test, in a team, so in my team, kind of dedicated to my team, but all of us would be able to use Java. So we're all engineers, But then we also have the use of AWS, or not specifically that, it could be any of the cloud tools I mentioned, and we know containers, and we know CI/CD. So you kind of get the picture, hopefully, that it encompasses a few different pieces there. So I think that's kind of a good the overview. Now, in terms of the application of this, and I think I've kind of followed through a little bit with it, but really, for me, what I think is important is it doesn't need to be that you are an expert in all of these tools. That the tooling, we should look at being tech agnostic. I think being an engineer that uses a specific language is useful. For example, okay, I use Java or I use .NET. That's useful in its own way. Or it could be you're a Python developer or Node or Go. These are all relevant. What's very important is that you're agnostic and you don't cling to the tools and technologies, because you might one day work in a company that uses a specific, it could be that we use Amazon Web Services in this company, and the next one you go to could use Azure, or we use Jenkins and that company uses Bitbucket. Okay, so you want to be able to absorb and be exposed to as many of these as possible. But what you're trying to get at, we refer to Jenkins and Bitbucket just now. What you really need to learn is continuous integration. That's continuous integration. We're referring to Azure versus Amazon Web Services. You're learning cloud computing. So you might be using various components there. You might learn some serverless like Lambda functions, or you might learn how they interact with containers like Azure Kubernetes service for orchestration. But you're actually getting at practices, you're getting at processes with that. And that's the underlying thing we should be teaching or learning, right? We should be learning how CI/CD works. We should be learning how cloud computing works, how containers and container orchestration works, how configuration management and provisioning work. And the tooling you use, I do think there's a number of popular tools that's worth adding to a core curriculum, but I don't think that we should learn them and think, I have to be the expert at every single one of these, because those specific tools might not be the exact ones you use. You're learning a collection of practices. So I think as the educators and the people doing the learning, I think both sides need to be very understanding of it's the exposure that's most important. And so in the case that we look at M3, where people, they come directly from university level, and they come and we bridge the gap between university and employment with our 8-week academy. It would be a case of exposure, and we tell our clients the same thing. So I would explain. So I do a lot of the business development and selling of our graduates, essentially. So it's finding new clients, it's getting them interested in what we do, and then it's saying to the client, here is how to best interview a junior person, and the same to the junior. How do you interview for this position? And I'm always trying to get them to engage on the same level. So it's not, you can't expect a person to leave university to be a fully fledged DevOps engineer. I don't think you can expect them to be a fully fledged software engineer. I think that what you're getting them to be is someone who has exposure to a wide variety of practices and a great mindset and ability to solve complicated problems using logic and solutions. So essentially, the faster you can get to the outcome, that's success. And outcome is a point I actually want to briefly touch on as well. So these high performing companies I've referred to, and these high performing teams, they are very much outcome based. So we said don't cling to the technologies you use, rather focus on getting to the end goal. We should not be looking at kind of the specific output of our team. We should be looking at the outcome. How do we get there quickly at a very high quality? And so one of the key pieces, I should have maybe defined this at the very start. How I define DevOps in pretty much one sentence is it's increasing the speed and maintaining or increasing the quality across the entire software development lifecycle in order to achieve maximum business value. So our outcome is maximum business value, and our goal is velocity with quality. And we've said maintain or increase quality, but we've said increase speed. So if you can do that, if you can imagine in a team and as a company, the speed you can achieve, if you can increase more speed, so you're going to then get more deployments, so increase your numbers of deployments, you're going to do deployments more frequently, and then with the quality, we're looking at things like, when we make changes to our code, we have less failures, so our change failure rate improves. The speed part, we're looking at how quickly we can repair bugs, so mean time to repair, mean time to detection, so how quickly do we find any errors. These are all kind of part of what we're looking at when we're referring to DevOps. And so if you can look at it from that big picture angle, where it's, what are we prioritizing in our team? What code are we working on, or what application are we working on? How are we going to get this done efficiently? Can I use a scripting? Can I script something? Can I automate something now that's going to, using another tool that's going to get me to that end goal faster? And so that doesn't mean we just learn tools like Docker for the sake of using it because we've heard it's interesting and it gets you a new job. We're learning it because we understand the application of such a tool would help us in achieving more speed and maintaining or increasing quality for that business outcome in the company we work for. So I realized that because we're doing this virtually, I'm trying to keep this relatively short and then get more to your questions so we can actually answer them. So I'm going to kind of have a pause moment and see, do we have any questions at this point that I can start to answer and kind of build our next few minutes from there?
There weren't anything really on the side panel, Connor, but I did actually have a couple that I wanted to just kind of go over with you, perhaps get the conversation started. In your opinion, are there any resources, specific reading material, websites, aside from the Durable DevOps podcast, which you host as well? What would you recommend for a student to really start to bring themselves up to speed within the world of DevOps?
Thanks, Lewis. Great question. And this is a really good point, actually. So it's not just doing what you're taught in class, it's actually the extra pieces. So some of the places, DevOps.com, I think that's the #1 website in the world for DevOps resources. So that's anything from case studies to interesting articles written in any format. It's Q&A sessions, there's podcasts on there, and also there's even funny pictures that can get across some of these pieces of education that we need. So DevOps.com, have a look on there. There's everything for everybody. OpenSource.com is great as well. And then also, so they're kind of like just the broad reading and learning aspect. Then when you're looking at a bit, some further education, I would say go to one of the cloud providers' own websites. So something like Amazon Web Services has a really, really great online kind of campus tool, essentially, where you can learn and go through all the modules at no cost. And then the only thing that has to be paid for is the certification at the very end, which is $150. But if you take all of the course, you don't necessarily have to do the certification to prove you've done something. You're learning so that in an interview you can explain what you know, and in your job you can practically prove what you can do and be part of the team. So things like AWS on their own website, go through their learning tools. Docker on their own website, docker.com. They have an intro to Docker as well. They'll teach you commands like run and exec and various other commands that you can go through there step by step and learn how to use Docker. And then you've also got similar, I believe, on Jenkins. There's things like Linux Academy. There's various other places where you can kind of do this online learning, which is very, very useful. Outside of M3, of course, and what we do.
Okay,
Sorry,
this is Jane Hayes. Jump in for just a second, if that's okay. First of all, I wanted to remind everybody we have about 9 minutes left, and we want to make sure that we hear a little bit about your M3 company and have a little bit of time at the end for just general questions. And then I thought that I would jump in with one general, I guess it would be an observation and maybe seeking some advice. So I teach software engineering courses in our department, as does Dr. Ting-Ting Yu, and I think she's monitoring a quiz while she's also listening to you all, so she probably won't be able to chime in. But in our CS 498 course, which is software engineering for senior design project, we definitely talk about continuous development, continuous integration, and in fact, I know that in some sections of that course, they use things like Jenkins and so on. In our senior design course, CS 499, which is the capstone course, the students undertake a semester-long project for real customers, and they're working in groups and teams, and they certainly experience the continuous integration and continuous development, and they work with a number of these different tools, but it's all specific to their project. So I might have one team that's using Azure, one team that's doing AWS, one team that's working with Docker, I mean, you name it. One of the things that we always struggle with as a department is, I mean, we have to teach the curriculum, first of all, the accredited curriculum. Second of all, we need to teach the underlying theory. We need to teach the principles and the fundamentals, and we can't turn into an organization that's basically just teaching the flavor of the week or the technology of the week or the tool of the week, right? I mean, that's what differentiates us from these other things that you can find online. So I don't know, I guess that was a rambling on, my apologies, but maybe there's a question to you all in that, which is, how would you advise a department like us that we're just crammed full with all of the courses we must teach in order to remain accredited? And of course, we would like to make sure that our students are staying up and are current and will be ready to move into the DevOps future. But there's, only so many elective courses we can allow them to take. I guess maybe, what are your thoughts on that? And I'm sure that we're not the only university in this boat.
No, and I think that's a good question and statement, Jane. I think I'll step in first, and I'll let Conor kind of go over his thoughts as well. But I mean, I think of it, and I've had the luxury of working with Conor now for 2 years, so I've been involved in a lot of his presentations. So it's definitely a topic, a methodology that I specifically see a lot of value in, because it's more not so much as saying this is the curriculum we have to change, but it's making sure that students have the mindset really to work within a DevOps environment. I give a good example that Conor always laughs at me for, but I think it's actually very pertinent, and he's validated as well, where it's, if you're working with a set of tools, would you prefer to have a bunch of individualized tools, or would you prefer to have a Swiss Army knife, one that can be a Jack or Jill of all trades that's multifunctional? I think it's teaching individuals, future technologists, to have that mentality that it's, while it's great to be a subject matter expert, it's also good to have a good well-rounded picture of everything else that's going around with regards to your team, the projects that you're functioning, and really making sure that you can do every task or keeping an open mind to do every task within the software development lifecycle, so that it's creating well-rounded technologists versus subject matter experts. And I really think that's overall the main point of teaching, of bringing individuals, making them aware of DevOps methodologies and really environments. And I'll let Conor kind of chime in with his 2 bits.
Thanks, Lewis. And Jane, I think that was really good to hear in terms of what you're doing at the moment. It does sound like you guys are doing a very good job. And I actually definitely understand how hard it can be to, without kind of pushing certain tools on people, teaching the same, yes, teaching the practices, yes, teaching cloud computing, but without using, okay, we use AWS for that. But the reality is, unless you build your entirely own tools, the fact that there is so much open source software out there and it is easy to access can help what you're doing. So the M3, we have our engineering course, our software engineering course is software engineering with DevOps. So it covers the things that we're talking about right now. And we simply do it in a way by saying, look, we're teaching you this using this specific provider. But like I kind of mentioned a few moments ago, this is not the be all and end all. So don't think that we're telling you to go and use AWS forever. Don't think we're telling you that Jenkins is how all CI/CD is done forever. But this is a really useful example of how to do it, in the same way that, we're going to learn software engineering, and okay, we're doing that right now we're doing that with Java, and we're going to use this for our backend code. And on the front end, we're going to use this if we're doing full stack. We're going to use these UI UX languages we're going to work with instead. So there's a way, you're going to always have to use something unless you build your own. But I think what you're doing already, working with companies, who are actually out there in the market, is one amazing way of doing it. Getting people to work in these teams is already a great way. So I think the question is very valid and it makes sense, but to me, it sounds like you're doing a great job already, and continuing in that direction sounds very good already.
Thank you. And then we have about 3 minutes left, so I know I would like to hear some about your company, and then maybe some other folks have a few closing questions.
Yeah, absolutely. I'll, for the sake of timing, I'll jump right into it and give you the quick overview. We're committed to partnering with Fortune 500 companies to help them establish a pipeline of emerging talent resources into their organization. The way we do that is we partner with universities across the country and globally as well to establish a pipeline of individuals whom we can bring into our organization, M3. We provide free paid training to students, recent graduates looking to really jumpstart their career within corporate technology teams. So the roles and responsibilities they can look forward to by joining M3 is really supporting the software development lifecycle with our client partners on exclusively allocated roles and projects for emerging talent through M3. Our goal is that after 2 years of working with M3 on these exclusive client projects, that our client partners will see the value that each individual brings to their team. They already have the knowledge of having worked on the team for 2 years. So for them, it's a very seamless transition to converting all of our employees to our client partner employees post 2 years. From our employee perspective, there's no contract, there's no hidden fees. If an individual is not happy, an individual wants to leave, they're free to leave. We have a mentality at M3 and an ethos really where it's based around, we want our employees to want to be part of M3, not feel like they have to be part of M3. From our perspective, if we give an individual all the tools to succeed, we make sure that they have the right training, that they have the right role for them, and they have support throughout their time and their journey with M3, those individuals are going to be in hiring capacities in 5 or 10 years. And we would hope that they had such a great experience that they would come back when they're in a hiring capacity to bring in resources through M3 similar to what they came in through. An individual won't come back and hire from us if we didn't do what we said we were going to do. We don't give them the tools to succeed, and ultimately if they had a bad experience. So our employee experience is one of the biggest things, drivers for M3. And again, we're currently hiring for software development roles, testing roles, production and application support roles. I'm going to add my email as well as Conor's into the comments section for everyone. Please, if you have any further questions due to the time, I'm happy to schedule a quick 5 to 10 minute conversation, give you a little more insight as to some of the current hiring initiatives we have, as well as some of the really great opportunities that we're currently sharing with other partners across the country. We're currently looking to bring in 400 new recent graduates between now and the end of August. This is all based off of our client demand and need on the projects that they have. So we're very excited. It's a very exciting time for M3 as we've had to pivot and deliver a lot of what we do virtually pre-onboarding with our clients, but I think we have the right infrastructure in place, a lot of the right subject matter experts such as Conor and some of the other training staff in place to ensure that we're able to seamlessly deliver the skills needed for our employees to be successful within their careers.
Thank you so much. That was excellent. And I'll add just 2 things. One is another student added on. So besides Ori, we also have Kashikaja. And the other thing I wanted to mention is you might want to get in contact with Jerry Smith. She's on our industry advisory board, and they're also in our industry partner association. She had a company called Galmont Consulting, and her idea was similar to your all's idea, and to have nearshoring that was going on for Fortune 500 companies, where she focused at first on software testing. Then they branched a little bit more into software development, and her company was purchased by SQS. So she's now gotten out of that space, but she's still on our industry advisory board. And I would say that she might have some interesting advice or maybe some lessons learned, or I don't know. And I have no idea what the size of your company is, but her former company still has offices in Hamburg and Lexington. So I could certainly get you her email address if you're interested in that.
Yes, absolutely. It's always good to start, to build a network, especially with individuals that have already worked in the industry. Everybody provides their own insight and mentality to how they see the industry going. So I'm always happy to have those conversations, Jane. Thank you.
Sure. Does anybody have any last questions for Lewis or Connor? Okay, well, thank you so much for coming to our Keeping Current seminar. Sorry about the little hiccup there at the beginning with the Zoom link, but we certainly thank our presenters today and everyone who attended, and Ari for taking care of our recording. So thank you so much, and everyone stay healthy and well.
Thank you, everyone.
Thank you, everybody. Take care. Thank you. Bye-bye.
Thank you.
Bye.